First of all, I have to, go on and say, Hilal, whatever you did, these works that I saw the past days of yours is exceptional and unique. The documentation is outstanding. So really, what Galip said, I just can underline it even more. It's a huge pleasure and honor to be here, and to start my presentation, I want to give the thank to these two people that you can see here, for sure, Professor Bichacho and Eric van Doorn, that besides MIS as a company made this possible and gave me this stage today here to have this audience and to share the next 30 minutes with you. So thank you so much for this. It's a huge honor for me, and I really am thankful for this. To give us a little bit of our outline during the next 30 minutes, I came up with these 4 topics for you, and you see that the diagnostic aspect, we looked into those parts really in detail over the last few or 2.5 days, but still I want to show you how we utilize it at the University of Geneva, and we used to do it at the University in Zurich. For sure, computer-aided design and manufacturing is a part whenever we think of the advantages of these new technologies that we're working with today. And then, all of this aligns somehow with new methods and materials that we are able to use today, which many of them you saw during, again, the last sessions and many of these beautiful lectures. And to summarize, I will show you the indications and also limitations that we see up till to now, and I will do this with the means of 3 cases, starting with let's say, a conventional, simple, straightforward case of a 4-unit posterior bridge, translating this to the anterior zone, and finalizing with a complex full upper arch reconstruction. The diagnostic aspect and the advantages of using this digital approach really comes out with this patient that we had the chance to treat in Zurich. She went on holiday for 2 weeks and she returned with this new set of teeth. So far, everything looked fine for her. The only reason she came to the office or to the university was the fact that she lost this 3-unit bridge in the lower anterior zone. And she only asked us to please re-cement it, and she thought she will be back and everything is fine. For sure, with your eyes, you see the inflammation of the tissues, and you can see that besides the aesthetic aspects, there is more things to doubt about this case and to tell this lady at this early point. And once we look closer at this lady, you see this is the cement gap. It's hard to believe, and this is the offsets nearly in all of the crown margins. So for sure, having this case done in such a short term, maybe she went on holidays for 2 weeks, it comes with these kind of limitations. But now imagine this lady, she's in front of you, and you have to tell her, we have to go back to 0. We have to start from scratch. And this patient had the reason to go abroad and have her teeth treated. The reason was a financial point of view. So there was the aspect, there was the need for her to go abroad, and now we start from scratch. And she has to, again, invest a lot of time and money to have her teeth done in a correct way. So what we tried and how we tried to utilize this new technology with her is we created a complete set of teeth, a digital setup for her, if you want to call it like this. And this really, I don't want to tell you anything, this takes a lot of time. To create these 27 teeth in her case, maybe you spend 4 to 5, sometimes 6 hours in really aligning the teeth properly, creating them, checking the morphology, checking the bite, all of these aspects. But once you reach the first set, it's very easy to save and store this and come up with a second version, a third version, a fourth version even. So what she or what we gave her as an option is she could bring us pictures from her early days, pictures from the magazine she might like. So we kind of pointed it out a little strong for sure, just to make it look nice and a little more impressive also for the documentation. You see a butterfly, let's say a Hollywood smile, very square, a diastema shape. And you see the interaction with this patient at this point of view early in this case, early in the road. And really she has the chance to feel and to try her new outline of the teeth. For sure, since we kind of pronounced them too strong, she asked us to do some small modifications, which we did, and we printed another set of this kind of diagnostic setup. Unfortunately, so far, our printer is not able to print provisionals, so at this stage we just have to use the same file and then mill the same reconstruction as a provisional and then finalize the case, which you can see here. The way we did it with single crowns in general is we try to be as monolithic as possible in the posterior zone, and in the anterior zone to have all the benefit of the aesthetic, all the benefit of the surface texture, of the layering, of the beauty of the ceramic. We will veneer very small and slightly only the buccal aspect of the anterior zone. And you can see her here smiling, the final result. And I think we achieved quite a nice result. She wanted these very bright teeth, but I think the most important thing, this lady knew ahead of time where the journey is going to lead her. This was a very tooth-borne, simple, straightforward case. But what happens if we go on and we go one step further and we try to utilize implant reconstruction into our workflow? And here basically the same thing happens. We do the same protocol as we try in these complex cases. The patient had the chance to choose in between the outer surface and the new design of his teeth, and then using this information, using the digital approach here by the cone beam technology, the surface scans of the technicians, and then understanding the position, understanding the need and the way how to place the implants according to the software. So I don't know how good you can see it. Here's the blue outline of exactly the provisional that this patient had in his mouth, exactly the line out that he understood where his new teeth are going to be. And with this, it's very nice and very easy for us to plan and place the implants according to the ideal and the planned new outline of this case. You can see the final done by your new Barcelona colleague, Manuel Sancho, that was used to work with us back in Zurich. Computer-aided design and manufacturing as a second topic, for sure, all starts with these intraoptical scanning devices. This, makes the thing change our lives, and especially your daily life in the office. What we see in the next 2-3 slides is comparing the two workflows that we used to work with as a optical workflow and the conventional workflow with a very simple, straightforward case. Just 2 anterior teeth that we try to replace. And you see all the things that we have to do ahead of time, preparing the teeth, cleaning the teeth. All of this has to be done in both sides. But for sure, the clean approach of an optical impression compared to this stressful approach, a little bit highlighted in this patient for sure, is something that the patient appreciates a lot. But you see the differences getting even stronger and more pronounced once we are in the lab side. And I'm sure all of you know this back from the school, from the dental school. Creating the models from the plaster stone is a tricky thing. And it's also dusty and it takes a lot of time. And you work in a clean screen and you create your digital model and you work with the files. If something goes wrong, it's very easy to just go one step back. It's not with the plaster model. You do one wrong cut, you lose your prep line, and you have to pour the whole plaster model again. The same, once again, when it comes to the design, because what we technicians love to do is waxing, but what you will see here is that 10 to 20 minutes I will invest my time just physically waxing material in order to have the new contour of the crown, which on the other side, in the digital approach, immediately I will ask the software out of the library to give me 2 crowns, and immediately I am there in the first 10 to 20 seconds to take care about the correct shape according to the patient's smile and according to the patient's demands. Is it a square shape, diastema, maybe more round teeth, more triangle? Immediately we are with the design for the patient. So here's advantages that we can see. For sure, we can do the same approach like you saw in the other cases. We can come up with 2 or 3 of these try-ins for the patient and provisionals, and finally finish the case with a small buccal veneering, and again, a case by Manuel Sancho. But does this give any benefit for us? Really looking into the numbers, besides that the workflow might look in a way appealing for the patient. So for this reason, we came up with the study concept and protocol in Zurich, together with Irena Seiler and Christoph Hämmerle. And we had the idea of comparing the two workflows. The digital workflow on the one hand side, looking into different optical scanning systems, and the conventional, traditional workflow. And you will see it here. We did this with single crowns and 10 patients, and we also did it with 3-unit bridges. You see the CEREC workflow has two groups. One is the chair side, the other one is the infinite end workflow to the external laboratory, CAD and Anterior, and the Lavas COS group, and we compared it with the conventional group. And now this is the most important slide, or one of the most important slides out of this 30 minutes lecture. You see the blue aspect, the orange and the brown is your time. Your time being a dentist, taking the impression, adjusting the crowns, cementing the crowns. There's hardly any difference. It's just a different approach. But if you look into the lab side, if you look into my side or Hilal's side or all the other great technicians, you see the time needed to create a conventional crown is much longer compared to a digital crown. So yes, there is a huge benefit when it comes to efficiency. Is there other problems when we look into this reconstruction of implant crowns? And yes, for sure there is. If we look into this review done by Ronnie Jung of the group of Zurich, you see that in generally speaking, the survival rate of implants for 5 and 10 years, they achieve to great numbers. So we see that the implant itself is a great concept to treat our patients. The crowns on top of the implants, however, have slightly smaller numbers, but still are in a very good range. What was also interesting for me is within the groups between the materials, like we also saw yesterday, there is no difference between the ceramic abutments or the titanium or metal abutments, and also there is no difference in between screw-retained or cemented reconstructions. There's differences when it comes to the way of complications. So for the cemented reconstruction, you find more of the biological complications. When you see the screw-retained reconstruction, you have more of the technical complications. But more, and for me, the most interesting aspect is once we look at this slide and we see the technical complications at 5 years, and we look into the technical complications itself. So what did they find? And they find that the framework fracture, the abutment fracture, is hardly not an aspect anymore. It's not an issue any longer. We are not fighting this. You see here the single crowns and the 3-unit bridges, or the bridges itself. But we are fighting really the topic of chippings. The chippings is something that borders our daily life and also our life of our patients. And you see here the incidence for chippings in the single crown is up to 3.5%. For the bridge reconstruction is more than 7.8%. So this is really some topic that we have to deal with besides all the other aspects of our daily business in order to make our patients receiving beautiful cases. So is there any new ways where we can kind of eliminate this problem of the chippings? And I think there is. The problem with this aspect is that actually what dental technicians love to do the most, and what we saw so beautifully documented also in other lectures, is layering ceramic, adding porcelain to our reconstruction, to our course, creating and giving all these beautiful surfaces, the colors and all the details that we are trained so hard. The problem with all of this is we are creating porosities. We have no chance to come up with something that is industrially produced. It's just something manually done within a lab with all the needs and with all the energy that we can put into this. And what happens if you look into some layered reconstruction, here a glass ceramic reconstruction on a zirconia frame, you see these small black dots, and those represent porosities. And these porosities, in summary, besides other aspects like function, they can lead to weaknesses within the material, and these might be the starting points, or these are the starting points for many of those chippings. So changing the philosophy of our daily workflow for sure is to think of something that is supported or given to us by the industry, and this is all these new products that we will mill in full contour. And just to give you a brief and a few examples of these new materials, one of them is resin nanoceramic, and you see just a monolithic reconstruction in here in the first molar. It looks absolutely okay to me. More complex, not really complex, a single implant here, 2 different brands, just stained and glazed, One of them is a hybrid material, like a composite, mixed with ceramic, and the other side, the lithium disilicate, the EMAX. Both of them absolutely clinically acceptable and beautiful due to the stain and glaze technique, but still it's a monolithic structure done and built for us by the industry. And this case really made me change my mind. It was a case that we did back in Zurich, I think 6 or 7 years ago, and we had to redo it for the fact that we used the wrong titanium base. And what you see here is the zirconia layered crown, and on the other side you see the lithium disilicate crown, just stained and glazed. So we had to redo the crown, and we were not really happy about it. It was just a mistake that happened in the lab. But if you would have asked me 5 years ago, my mother needs a crown, what would I told her? What crown would I created for her? For sure, I would have created this type of crown because I would have had the chance to give her all my knowledge. I could have layered, I could have given her the best color, the best appearance, the best surface. Today, looking into these pictures, in the posterior region, I have to admit, I have to change my concept. I have to change my philosophy because with this, there's hardly any chance for chipping. There's hardly any chance for any kind of stress that this crown might receive over the time. Here, on the other hand, we have to invest a lot of time on the first side, plus it even looks the same. So there's really an indication to use it. So posterior reconstruction. The only problem is with all these materials, they only work for single crowns. But unfortunately, the single crown is not the crown that we deal with every day. So at some point, we have a 3-unit, a 4-unit bridge to deal with. And all these new and beautiful materials that are done and presented to us by the industry basically stands for single-tooth reconstructions. And the moment we look into this example of a 4-unit bridge on 2 implants, basically there's only one material left to deal with, and you will see the zirconia. You see the try-in of the zirconia, the stain, the glaze, and the final reconstruction. I think for the posterior region, absolute, something that we can deal with, something that the patients appreciated. And we have the strength, and we have the surface texture that allows us to create a resistant reconstruction for these patients. But the moment we move to the anterior zone, the things become more tricky, because if you see this, the patient holds onto this tooth, and we come up with 3 monolithic reconstructions, just a try-in, and you see there is no chance that this patient will accept this type of reconstruction. So for the anterior zone, absolutely yes. We need the technician's work, we need all the skills, we need the layering technique, and we need to have some kind of aesthetic layering in order to achieve this kind of aesthetic and this kind of results that our patient wants and want to take along and home with them. So what is the indications that we see to utilize all these new techniques? And absolutely the indications for us today is everything looking into diagnostic. And I'm sure we will see with Christian another 30 minutes of amazing diagnostic approaches that he will present to us. But here there is a huge strength when it comes to the digital workflow. Models, on the other hand, made the life quite tricky at the moment, because we can create all of these models that you also saw during the past days, but combining them with the different implant analogs, combining them with minimal invasive approaches is not easy in all the steps. So here, I think we still need to work a little more. Simple, straightforward cases like this, they work perfectly fine with the digital workflow. Also 3-unit bridges, perfect. Single-tooth implant reconstructions, an easy thing to do. In most of the cases, you can even don't use a model at all. If you think of these beautiful thin laminates or veneers, I think we need a model with all the details. If we are not able to mill it because it's so thin, maybe 0.15, 0.2, to achieve this kind of results, minimal invasive, so far we go back to the traditional workflows. If you see a case like this, however, you have a very monochrome color and the patient just dislikes the color. We don't want to redo the whole case because it's done a few years ago in another country, but she just has the aesthetic demand. All the implants are fine. you can achieve amazing things with digital approaches. Milling reconstruction out of lithium disilica, just staining and glazing them without any kind of models. It's amazing what you can achieve. You can even, by adding these colors and stains, you can achieve something like translucencies out of monolithic reconstruction, which I've never believed 3 or 4 years ago. But today, the industry offers all of this. So here, I think we can give a great benefit to our patients. And now to summarize, for the last 10 minutes, 3 cases for you, how we deal with the digital workflow in our daily lives in Geneva. And I show you the first case that was actually done back in Zurich. And you see really the straightforward case, 4-unit bridge. We plan to have 2 implants. We do the diagnostic, as you saw before. We do the try-in. We're doing the superimposition, as you also saw in many of the other lectures. Planning the implants according to our prosthetic outline, which you can see here, the blue wax up. Placing the implants according to this, planning the implants according to this, creating the surgical template, which is amazing to do this with this kind of softwares. If I think back at the times of Med 3D or IVS, where you had to physically do this yourself in the laboratory, it was a lot of work and there was so much room for error. Today, really, with this, you create this kind of stents in 2 to 3 minutes. Bringing it into the mouth, doing the surgery, putting everything together, recreating, and this is for us the critical aspect, using the same initial setup, the same initial design that we printed for our mock-up, for our setup, and we create the provisional for this patient. As you can see also with Gallup-Gurel's lecture, we always use these Maryland backings to have the better positioning of the reconstructions here at this stage, and then we place our provisional here, tooth born in the first place. We do the abutment connection, we place the same titanium cylinders, and we just reline our reconstructions. So without having any new impressions, we are able to have a implant-born provisional, as you can see here. And finally, we recreate the same kind of setup for our final reconstruction. So this is completely zirconia monolithic, as you can also see later on. And yes, we add a little bit of ceramic here and there if we think that it might add up nicely to have a better contour or a better fit. But the worst case scenario, there will be a minor chipping, yes, but it will be so minor that the patient will hardly see it or feel it. When we are in the anterior zone, it will be again more complex because we are fighting with more aesthetic demands of our patients. So the patient came to us, he lost his 4-unit anterior bridge, the tooth fractured, and you see we took out the roots, we did some ridge preservation, and once again the same technique all over. We did the setup, the digital setup for our patient, we did the planning according to this digital setup, we placed and we created our surgical template. The implant surgery was performed in order to thicken the tissues, as you also saw with Gallup and Eric von Dorn's lecture. We thickened the tissue with the free gingival graft here. And then we recreated once again our virtual setup, virtual try-in with the milled provisional here in the multicolor blank. Once again with the Maryland backings to give the support and to have an easy access while positioning those. We understood in these days that we have to apply the opaque material, the composite opaque, in order to avoid the grayish discoloration of our provisionals. We relined the whole provisional here and united with the provisional abutments. And as you can see here, there's the first limitations. This is just out of the mill and polished. There is no touch-up done by a technician, no beautiful morphology, no nice approximal areas. It's just how it is. So for the anterior zone, it becomes tricky to use the complete monolithic reconstructions as they are falling out of the machine. So for the final reconstruction, we always keep this in mind, meaning we will have the full strength of the material in the palatal aspect around the screw channel. We always want to have the reconstructions directly screw retained, as you can see here. But for the buccal aspect, we will have and want to have a minimal invasive, let's call it a minimal invasive layering technique, in order to have beautiful approximal areas, in order to have the beautiful surface texture, as you can see here, and that you also saw with many, many of the other lectures. Creating this in a monolithic way is very, very difficult, and also playing with the lights, like you can see here on the other cases, is much easier if you apply the ceramic. But keep in mind that this ceramic that we apply manually just doesn't reflect the strength that our monolithic reconstructions do and deliver for us. So here's the final patient with this, I would say, minimal invasive layering just in the anterior zone. And now looking into, let's say, the full power of all these digital processes, you see the complete kind of restorations that we did here together with Eric van Doorn and his team, and also using the MIS and V concept. You can see here the placing of the first implant. He placed actually 6 implants in the upper jaw, also 6 implants in the lower, and we had the chance at this time point to start with an optical impression, plus to be on the safe side and to assure the perfect fit, we also did a conventional impression. We milled our setup. I had to adjust it to small bite configurations, do all the silicon index, as you also saw within the other lectures, create and adjust our titanium cylinders. We always want to use the longest available ones to have all the strength, just shorten them, scan the whole thing, plan once again, adjust our reconstruction according to our initial setup that we did for this patient that he could wear as a provisional. For sure, this was removable. Now we are moving back to something fixed, so we have to deal with the transition line in between the surface of the tissue and our reconstruction, which is not always easy in this type of case, but you see here we managed. And what happens once you design these kind of cases? You design them very beautiful and you spend a lot of time and efforts. And the moment you take them out of the machine, unfortunately, they don't look like it anymore. So what is the problem here? And this study done in Sweden, in Malmö actually, explains it really, really nice to me. And I think I didn't find anything better and more visible than this study. So what they did is like, they did 4 kind of reconstruction based on a 3-unit bridge. Conventional wax up, milled wax up, and then the lost wax technique, milled framework, and the laser sintered framework. And now if you look into the numbers and the accuracy, you see what we use the most is all the milled reconstructions. They basically offer us the worst fit. It's not worse in a sense that it's not clinically usable, because in the marginal areas, the fit is very nice to all of the systems. But we are having problems in certain areas. And you will see the certain areas here on the one aspect. It's the inner side of the fit. So all these sharp angles give us a hard time. But you see also this problem now looking into the monolithic reconstructions. You see them on the buccal aspect, because the machines are just not able to mill all these beautifully designed aspects here that you can see if you compare these 2 data. It should be the same. Unfortunately, it's not so far. So here we are struggling. It's maybe something that will be solved in the future, but all the beautiful approximal areas here, I have to redefine myself with time. Once again, it's also very nice to look back into your draw and look at all cases that I did and look at how invasive we were with our layering technique compared to what we see and use today. This is the frame before the sintering, after the infiltration process, and finally after the sintering. And you see once again the complete occlusion is monolithic. The complete frame is basically, I would say, 85% monolithic, and there's only a buccal veneering needed. This is a little bit of dentin, enamel, and some artificial gingiva, much faster than I ever was able to recreate this kind of cases. And once there is a chipping, it will be really minor compared to back in the days when we had massive chippings in these type of reconstructions. And with this final smile of the patient, and once again, thank you, Eric, for trusting in me to doing this case with him, which as you know, the stakes are high. And I want to thank my team, because in the end, as also the others mentioned, this is a big privilege to be here on stage, but in the end, the things only work if we're working together hand in hand. And yeah, we are also enjoying our lives there in Geneva. And with the view of the Lac Léman, I would like to thank you so much for your attention, and once again, thank you for the chance to be here.